water balloons, a classic pastime to go wild with your friends. Water brings out the fun of us, especially those epic wars. But how effective have you been doing it? So today, we decided to explore the physics of throwing and popping a water balloon, along with covering how to maximize the biggest splash possible. So next time, you become the biggest splash. As you can see here, this is the goal. Popping the water balloon on the board and creating a huge area of impact.
Here's what we are working with. Our small water balloon is 350 grams. Since 1 milliliter is 1 gram, our small balloon is 350 milliliters. On the other hand, our large water balloon is 600 grams or 600 milliliters.
Since we're such great scientists, we came up with a hypothesis. Our statement reads that the larger water balloon will have a greater force of impact and a larger splash area than compared to the smaller balloon. As to note, we will have the same thrower throwing the two water balloons.
To start, square up your body with your target. Next step, your foot opposite to the hand with the ball while your shoulders line up with the target. Move your hand back and hold at a 90-degree angle behind your head. Hold this position as far as back as possible.
But how much force is needed to throw the ball? Or how much force is the balloon impacted on the board? Or what's the velocity of the ball? We'll figure it out. To find the velocity of the water balloon, we must find horizontal and vertical velocities to calculate the total velocity. For the horizontal, we set up an equation: distance divided by time in the air, time being the time it takes from the ball being released to hitting the board. To find the vertical velocity, we had acceleration due to gravity times time of the fall. Time of the fall being half of time in the air, due to it being the peak. And after plugging in our values, here are the two numbers. Now, to find the total velocity, we must solve using Pythagorean theorem. It is a squared plus b squared equals c squared. So we'll take this value, we'll put it in as a, and this one can be b. So of course, these two values were squared from this value and this value. Add them together to get this, and you square root it. So you get rid of the square root on c, and you get 10.845 meters per second, which is velocity total for our big balloon. For our small balloon, we got a faster time of 12.43 meters per second, using the same method as before. If you're confused about these numbers, take a look at this video from Usain Bolt. He runs approximately at the speed that we throw the water balloon. Crazy! To find the force of the impact on the board and the force out of the hand, you set up an equation: mass times velocity equals force times time. We must separate F, which is force, by multiplying the left side and then dividing everything by the time. Then we get newtons equals force. This is the premise of our four equations. The force out of the hand should be 30 newtons and around 17 newtons. Our impacts were 150 newtons and 260 newtons.
Wow, what a hit!
Great throwing by Josh. On the left, we have the big water balloon splash, and on the right, we have the small balloon splash. The winner is the big balloon.
Our hypothesis was correct because the bigger balloon created the most radius and the most force. Our video was the best because of water.
Oh, shoot! Oh, midair!
Throw! Go! Throw!
When to go?
You missed.
Nails in the headshot.
I hit you right in the
I know.